Okay, so I'm going to be solving problem 6.2, which is asking us to find the max percentage overshoot, the peak time, the 100% rise time, the settling time, and the delay time. So the first thing you need to do is get this into the characteristic equation, which I already did here. That's s squared plus 4s plus 8 equals 0. And now I'm going to use the quadratic formula and solve for the roots. So when you do that, you get s equals -2 plus or minus square root of -4. So s equals -2 plus or minus 2j. Those are our roots. So then we need to draw um, the plot in the S domain, or the imaginary domain. So to do that, we have a real axis and our imaginary axis. So I'm only going to draw the top half of the plot. The bottom half will be the same, just mirrored over the real axis. It doesn't actually matter the way the equations work out. It ends up being the same for the things that we're solving. So the real part of this root is -2. So I'm going to draw a point at -2, and then the imaginary part, I'm going to do the top, so it's positive 2i. So this is -2, positive 2. I'm going to go ahead and draw this line here. And this line is given to be the natural frequency. And the real part is zeta times the natural frequency. And zeta is the damping constant. And then this is the damped frequency right here. So some equations that we're going to use, zeta is just equal to cosine of theta, where theta is this angle here. And that is also equal to, so cosine is adjacent over hypotenuse, so that's zeta over omega n divided by omega n. So in this case, that is just 1 over the square root of 2. What is next? We also need to find the damp frequency, which is omega d, and that's just simply the value of the imaginary part, such as 2. And then the natural frequency is just the, you just use Pythagorean theorem, so it's this part squared plus this part squared. Take the square root of that. So that's 2 times the square root of 2. So then, first we're going to solve for the max percentage overshoot. So m percentage is the notation for that, and we're given that it's equal to 100 times e to the negative pi zeta over square root of 1 minus zeta squared. And so you just plug in these numbers up above. So zeta is 1 over the square root of 2. And it comes out to, actually, if you simplify this down, it comes to 100 times e to the negative pi. And this is just 4.3214%. Then for peak time, so TP, we are given that this is equal to pi over omega n times the square root of 1 minus zeta squared. And then once again, just plug in omega n and zeta. This just comes out to pi over 2. And then 100% rise time. It's just, we're going to label this TR, and that is given to us as 2 pi minus phi over omega d. I'm getting all these equations, by the way, from table 8.3.2 from the book. Okay, so the rise time is 2 pi minus phi over omega d. And phi is given to us as, phi is the arctan of square root of 1 minus zeta squared over zeta plus pi. So just plugging in the numbers from above gives us 5 pi over 4. So then using this as phi and the numbers from above, we are given the rise time to be 3 pi over 8. Okay, and then next is the 2% setting time. Sorry, settling time. That is just 4 times tau, which is 4 times 1 over zeta times the natural frequency. So just plug in the numbers for that. That is just 2 seconds. Everything in here is in seconds, by the way. And then finally, we need to find the delay time. So that's just given to us from this table again as 1 plus 0.7 times zeta over the natural frequency. And just plugging the numbers and calculating that gives you 0.74749 seconds.